Good morning. This is CSE 455 Software Engineering, Spring 2020, the 3rd of August, Wednesday. Today we'll be talking about um, the last requirement for the documentation of your projects. Um, we have, or I have told you that the revised software architecture and design, uh, I will accept your correction by finals day, the 10th of June, for partial credit. Um, the test report has been distributed to all of you development teams. So fix all the errors and show that it now works in iteration number 2 or prototype 2 on finals day. And here is the last requirement for the documentation. Submit your maintenance manual and store it in your repo. We would check whether it is there on finals day, the 10th of June. And as you know, on finals day, you deliver your iteration number 2 or prototype number 2 on finals day, the 10th of June. So we'll begin the process again of QA testing. Okay, so what is the maintenance manual? This document talks about uh, the kind of a note to the next team of where everything is in your development, source code, SRS, SPMP, SAD, and some hints on your development. So here is an example from 2 years back. It's called Optimal State of Living. And this was done to satisfy a requirements by a kinesiology professor. Her name is Professor Amy Wheeler, for an app to help firefighters, policemen, soldiers to relax and avoid um, or control their tension, and so uh, reducing stress through yoga and other dieting and exercises and so on. So the first section is the structure of your file. So on your repo, how are your files are stored? Placing the name, writing the name of the file, and what is the code for. So you see here, these are Java code, and there could be other files that pertains uh, to the database. If you're using Firebase, you also write the name of the file and where are they. If it is PHP for server, you also write PHP files. And if you are using a web service, let's say you're using Laravel, that is in PHP, where are those, what is the name of that file and where are they located? Okay, so here you list all the files that you use in your development, and um, you in this document you define what they are used for, and um, and their the names of the structures that you have used. Section 2 is an instruction on how to run and how to compile and build the app. So here is the instructions on how to do that, compiling and creating the executable module, and then how to run the app on the Android device. Okay. So it will help, the maintenance manual will help a succeeding team who would inherit your work regarding where are the files, how to compile and build the app, and how to run it. Section 3 is kind of um, a section for listing what is good about your implementation, what is positive and novel in your implementation. So they should know that. And also, you also write things that needs improvement, weak points. What are the weak points in your implementation? Needs improvement. And then section 5, what are your overall recommendation? So this is a document handed over to the next team on this overall recommendation of the project. Okay. So I want this manual, maintenance manual, to be included in your repo together with your SRS, SPMP, software architecture and design, source code, and this maintenance manual to be part of the documentation. Okay? All right. So QA will check that you have created this document and indeed it is in your repo. Okay? Okay. Let me get out of this and come back to the maintenance, to the lesson today. And next one is the software review process. We have talked about this, but now I'm going to summarize everything that we have done in terms of software review. So software review is a process or a meeting during which the software product is examined by um, a personnel, project personnel, or manager, users, customers, user representatives, or other interested parties for comment or approval. And this is a way for a way for the the process is or the document or whatever is the software project is is uh, being reviewed. Okay, let me go to this uh, link before it disappears. Now, software review, as I said, it is a review of a software product. What is a software product that we are talking about here? The software product could be project plans and budget, and that's the SPMP, Software Project Management Plan. Requirement specification, what are your documents for eliciting requirements from the client? Specification is the SRS. The design is the software architecture and design. And of course, source code is the source code. And other software products that is being um, reviewed. So the purpose of the review is to um, detect errors or inconsistencies early in the design or early in the development, the software life cycle. Okay, so uh, uh, the kinds of software reviews are software peer review conducted by the author of the work product. So if he is the uh, project manager or assistant project manager, then it is the SRS or the SPMP. If it is the design, then it is the software architect. If it is the source code, then it is the software engineer, and so on and so forth. There are also software management reviews conducted by management to evaluate the status of the work done and, of course, the budget. Where are we? Uh, Software audit reviews uh, to evaluate the compliance with specs, standards, contractual agreements, and other criteria. And part of the software review is the code review, and we will talk about that later on. Okay. Now, there is a document by IEEE that actually specifies how a software review is to be done. And that's the IEEE Standard 1028. This is for formal review. And here is the format of the document, okay, as you can see here. Okay. And the purpose of the review is to determine defect detection process. We want to find out errors early in the or during the software life cycle. Okay. All right. Now, going back to uh, to our topic, the software review process. If you remember, we did a review of the software requirement spec. You remember that? That is and here you have let me get that figure right here. If you remember, very early on in the software requirement specification, we have the use case diagram, as you see here, and you have the field officer. Remember the emergency system that we talk about? So we have use cases and we have actors, okay? And then we review the software requirement specification through a sequence diagram. Okay, remember that? Okay, and in the sequence diagram, we determine objects which could become um, classes or modules or components in your software, but we uh, kind of have a scenario of how the field officer is going to use the software. Okay, and we identify the emergency button on the user interface, and then we identify an object or a module or a component that does a report emergency control. And there is here another interface called report emergency form, and then another object called manage emergency control. So we analyze how the field officer is going to use the system. Okay? And then what happens is that we also take into consideration what the dispatcher on the other side will be doing when it receives the report, emergency report. So the managed emergency control is the same managed emergency control in the officer side. And then you have the incident form. This is a user interface that the dispatcher use for creating the incident report, object incident, object acknowledgement. And then as soon as the dispatcher finished uh, responding to the report, the field officer um, receives the acknowledgement notice. So this is a software review. And the document we are reviewing is the SRS. And I ask you to include a analysis on your SRS, and I offered an extra credit for any team who would do a software review using a sequence diagram and give you extra credit, but unfortunately no takers. Okay, so I cannot give extra credit because nobody tried it. But this is the software review of software requirement specification. So as early as the SRS, we try, it is ideal that you conduct software review so that we can detect defect as early as possible and correct it early in the software life cycle. So this is a great advantage of doing this. Okay, so there is this SRS review. Okay, next is the design review. We did a software design review, if you remember, in the elevator project or the elevator example, where we derive the low-level design of the elevator, and this is what we come up with. Okay, so here in the in this class diagram or low-level design, we reviewed the class diagram by means of a sequence diagram again. Okay, so we use sequence diagram on how to analyze. And how did we analyze the class diagram or the low-level design? Well, on top of this sequence diagram are all the objects or classes in your design. So notice here that the floor button, the elevator button, elevator controller, elevator, and elevator doors are names of classes or objects in your design. See? Okay. And how did we analyze the design if it is going to work? Well, we have a scenario. Again, of how the elevator control system will work. So, as you know, sequence diagram increases in time as we go down. So, the scenario was the first thing is pressing the floor button. So, which object receives that input of the floor button being pressed? So, that is received by the elevator controller. After some time, the elevator controller will turn the light on. And who has the light of the floor button? It is this class that has that light. Okay? And since the floor button was pressed, the elevator controller will command an elevator to move up. Well, moving up because that elevator is assumed to be below where that user is, and therefore it is coming up to uh, fulfill the request for an elevator. And then after some time, it will arrive, it will turn the floor button off right here. So in other words, you are exercising your design through the scenario. What happens in this scenario? And this scenario is very important in the review of your um, low-level design, the class diagram. And if you remember, I also recommended that you include abnormal scenario so you can anticipate unusual situation where your software is subjected, and therefore you will be able to see if your low-level design can handle an invalid input to your system. Okay, so um, that is a review of your software design, and the software design is the class diagram. Now, how to apply it to high-level design like packages and components, it's a little tough on how to do that. But it can be done by an architect who is experienced in design of a system. Okay? Now, we can also do a detailed design review. If you remember that example that we have in the okay, I think this is the one. Okay, remember in the detailed design of the elevator control system, we uh, we wrote the pseudocode of the elevator control loop. So this is a function of um, uh, the elevator control class, where there is an elevator control loop. Okay, and we wrote it in pseudocode and not the syntax of the language. And we say we will review this using the recommended for software review is to have what we call a checklist. And so these are guidelines on what to check in your uh, what to check in your review. Okay, so it's not done haphazardly, but a well defined process on how to review your detailed design. So here is an example of a detailed design review checklist. It's um, it's a good software process to actually have a checklist, which is recommended, and not do a random or haphazard way of reviewing. Okay, so you have here the how to do an effective detailed design review checklist. Now, these two are names of the modules that you are or classes that you are um, reviewing. Okay, so here is a general instruction. As you complete the each step, check that the item check that item in the box to the right. So if it satisfies, you check it. Well, I cross it, so it's the same. and complete the checklist for one program unit before you complete the next. Okay, so you proceed with here we have a Gaussian elimination class that we have implemented, and we are doing a detailed check. So completeness, so ensure that the requirement spec, the SRS, and high-level design are completely covered by the design. So remember the software requirement specification gives the use case diagram, and therefore the high-level design should cover all the use case that is in the SRS. So all specified outputs are produced, all needed inputs are furnished, and all required includes are stated. Okay, so this is checking for completeness, referring to the SRS use cases. You use your using the SRS and the high-level design, make sure that they are satisfying those use case. Okay, checking the logic, verify that the program sequencing is proper. So here are examples. Stack lists are in the proper order. Recursion unwinds properly. And verify that all loops are properly initiated, incremented, and terminated. So using this checklist, you'll be guided along in your review. And checklist has been used in many other disciplines. So, you know, the launching of the first rockets or space rockets after 9 years that NASA and SpaceX are collaborating. There is a checklist that they use to decide go or no go for their flight, okay, for the launching. So they use that, and also in airline pilots or fighter pilots go through a checklist before they fly. Similarly, in accounting, accountants do a checklist to make sure that their work is complete. So checklist is used everywhere, and we do that here for the detailed design. Did you check for special cases like check for empty, full, or minimum, maximum, negative, zero? This is a very common error. Out of limits, overflow, underflow. Ensure impossible conditions are absolutely impossible. So if this condition is impossible to happen, you must make sure that it is really impossible to happen, because if it happens, of course, your code didn't handle it, your program could crash. Did it handle all incorrect input conditions? Remember, invalid input? Make sure that all throwable statements are enclosed in a try and catch blocks. Okay, so there's always a handler for any kind of condition you can think of. Functional use. Verify that all functions, procedures, or objects are fully understood and properly used. So this is a reminder about the correctness of your functions or procedures. Verify that all extremely externally referenced abstractions are precisely defined. Okay, this one is probably taken care of by your IDE, where it watch out for misspelled variables uh, and scoping of the variables. But it was included for completeness. And of course, the last one, that if you are following standard, are you following the standard for design? So even though This is pseudocode of the function or of the object. It's going to be reviewed as well. Okay. All right. So we did the software design review and the detailed design review. Now, next is the code review. Now, this has been lately emphasized, and it is, late years that was emphasized, and but now it's all coming back. Okay, I remembered when I was a grad student, and computing is very expensive there. We were running mainframes, and the only way to use the mainframe is go to the computing center and use one of the terminals in that building, and you pay for computing time. So the use of the computer is not free. We should pay for the use of computers. So I believe it was $50 for the use of the computers for one semester. Okay, way back when. I will not tell you which year, but it was very long time ago. Okay, and I was so anxious to run my code that as soon as I finished coding, I submitted my code to the mainframe. Okay, and then before I noticed it, the program went into an infinite loop, and before I hit escape or abort, it runs through my program and consume all my $50 of computing time. So I have to pay again another $50 worth of computing. But you guys right now have practically free computing time. You can run as much as you like and not worry about paying for computing time. But during those times, we are paying for computing time. And so I learned my lesson during that time, that before I submit my code, I review my code. Okay? And code review has been coming back for the last 10 years. Code review, or 5 to 10 years, code review has come back, and it has been reported that the code review is effective. Okay, look at this. This is a paper that is in the ACM Digital Library. You know what is the ACM? The Association for Computing Machinery. It's the first computer organization, and I hope you guys are members of the student chapter of the ACM. Here is a paper about the impact of code review coverage and code review participation on software quality. This is a case study of 3 projects: Qt, VTK, and ITK. Well, I don't know what those projects are, but they are probably names of projects where they applied code review, just like ours, Know and Vote, UDrop, Bubblein, and so on projects. So here is the abstract of the paper. Just reading you what is the paper all about. So software review, code review, the practice of having a third-party team member critique changes to a software system is well established best practice in both open source and proprietary software domain. So it is being used in open source and a proprietary software domain. Prior work has shown that the formal code inspection of the past tend to improve quality of software delivered by students and small teams. However, the formal code inspection process mandates strict review criteria like in-person meeting and reviewer checklists. So they the emphasize uh, the formality of the meeting. So it is not just a haphazard meeting, but a formal in-person meeting and using checklists. Ensure a base of review quality, while the modern lightweight code reviewing process does not. So the informal way and lightweight code review does not do well in determining the quality of the code. Although recent work explores the modern code review process qualitatively, little research quantitatively explores the relationship between properties of modern code review process and software quality. Hence, in this paper, we study the relationship between software quality and code review coverage, the proportion of changes that has been code reviewed, and number two, code review participation, the degree of reviewer involvement in the code review process. So through a case study of these projects, which I believe was done in a academic environment, so much like our class, if we want to study the effectiveness of code review, we could have done it to three of our projects. As I said, maybe Bubblin, UDrop, and Coyote Quest. And we find that both code review coverage and participation share a significant link with software quality. So software quality, according to this paper, was improved. Low code review coverage and participation are estimated to produce components with up to 2 and 5 additional post-release defects respectively. So they are able to find out two more, uh, 2 to 5 additional post-release defects. So it pays to do a code review. Okay? Our results empirically confirm the intuition that poorly reviewed code has a negative impact on software quality. So if you didn't do it right, software quality is affected. So in large systems using modern review tools. Okay, so not only that, there are other code review quality. Here is another paper investigating code review quality. Do people and participation matter? So this is a paper that was done to open source. Okay, so code review is a part of our software process, and it's not anymore a thing of the past where computing time is very expensive. Okay, so this was in the proceedings of 2015. Okay, IEEE conference. Okay, so code review uh, pays in terms of doing it right, using a checklist, and using a formal meeting to actually carry out the code review. Okay? All right. So um, let's um, look at the uh, Java code review checklist, and that is here. Let me show you that. Um, Here is a Java code review checklist. So we use this in doing a code review for Gaussian. We were doing Gaussian elimination and Gaussian testing of matrix. So here is the checklist for Java code review. So as you complete each step, check the item in the box to the right. So we do a check if it passed. So this is the name of the module or the name of the class. Complete the checklist for one program unit before you start to review the next. Now, for completeness, verify that the code covers the design. So make sure the code came from the detailed design. Okay, remember what I was telling you about tracing? That is, make sure that the source code came from the detailed design. So make sure that's a proper translation of the pseudocode detailed design into source code. Imports, verify that the imports are complete. So if there are imports that you are calling, make sure they are part of the source code. Check variable for initialization. Initialization of variable and parameter initialization. Program initiation, start of every loop, function method entry, new instantiation correct, or reference initializations correct. So sometimes the initializations are the cause of problem. Calls, check the function and call formats, parameter types, descriptive names of the parameters. Output format, is the output in a readable, intelligent format. So that's a check for the intelligent format. How many of you have had this problem? The an unbalanced curly brackets. Although IDEs now catch this, the um, uh, the imbalance curly brackets, but sometimes if it is missed, it is a very hard bug to fix. How many of you have made the error of instead of an equal sign, you have equal equal, and the two are syntactically different. The uh, the the two parallel bar, two ampersand sign, and so on. Check the every logic function for parentheses, okay? And although, as I said, IDEs catch this now. And line by line check for instruction syntax and proper punctuation, okay? And these are, as I said, um, uh, hard to debug. If the IDE miss it, then it may take you a long time to detect that problem. Standard, it ensure that the code fits coding standard. Remember what I told you about coding standard? Now, coding standard should be kept to maintain readability of your code. And this is not for you. It is for the next team who will inherit your work. And following a coding standard will improve readability and um, um, allow the maintenance of your source code easily. And open and close files ensure that paths are reasonable. So remember the cyclomatic complexity measure? The higher that number, the more complex the algorithm is. And so the more complex means the more error that could occur. And so if the cyclomatic complexity measure is high, try to restructure your algorithm into a much lower cyclomatic complexity metric. Okay, and uh, files, how many mistakes we have made in failing to open a file or close the file if necessary. So the checklist plus the formal meeting for review help facilitate the review process. Okay? All right. So before I go to the next topic, let me pause here for a while and okay, let me end the lecture by talking about average salary of QA engineer, average salary of software engineer, and the average salary of a software architect. I would like to point out the expertise of these three levels of uh, people in software engineering. So let me show you the pay scale of an quality assurance engineer average salary. It is a median of 69,763 to a low from actually 51,000 as the lowest and 97,000 as the highest level of salary. And the median is around 70,000. So the quality assurance engineer does exactly what the QA team is doing. They prepare test cases and run the testing of the software before it is released. And this is the entry level of many of our software engineering graduates if they don't have a experience, just an entry level. Usually the job is a QA engineer. So you have an average of salary of 69,763. Okay. Now, for the average salary of a software engineer, here is the pay scale. According to pay scale, the lowest salary is about 61,000, about 10% of that, and 90% has 126,000. So the median, the highest here, and the median is 85,539. So the main task of a software engineer is development. They do coding, and they are responsible for the low-level design. And you become a software engineer after years of experience as a QA engineer. And so from QA, you advance to becoming a developer. You are involved in developing. So, it has a higher salary than the QA engineer, and the QA engineer receives source code from the software engineer for which they test. And it is the responsibility of the software engineer to implement the software design. Okay, so who does the software design? Okay, of course, it is the software architect who makes the design. And here is, according to pay scale, the average salary of a software architect, 124,099. This is the median. You can get as low as 87,000 to 163,000. But the median salary is 124,099. So the software engineer cannot begin their job of coding before the software architect gives the design to the software engineer. And usually, the design is in the high-level design of packages and components, and the software engineer breaks it down into class diagram, and the low-level design is coded, and once the coding is done, the QA engineer takes over. So the software architect is the decider of how the software will be implemented. So the software engineer cannot begin the job of coding before the architect is done, and the QA engineer cannot begin their process of testing uh, before the software engineer finish coding. So the architect is, as I said, the highest paid individual in a software development because uh, eh, we rely on the software architect to come up with a design of the software that is going to be determining the different components of your software and their interrelation to each other. And once that is done, which is the high level design, the low level design can be determined by the software engineers. And so it is a level of responsibility that determines the salary of personnel in a software company. So the architect is highest paid. Of course, if you rise up in your position, like you become a team lead or you become a assistant project manager or project manager, and there is also like the VP of software engineering or the VP of software production. Those carry a lot of much larger salary level, but your responsibility also um, is higher. So the higher the salary, the higher is the responsibility. And you become a software architect through experience. You cannot just say, oh, I know the steps in the software design, I can do it. But once you come up with the design, how do you know your design will work? Okay? So it is through experience that the architect has a high salary because of experience. He has a lot of experience in designing software design, that he is paid that big bucks because of his skill in developing software design. And the software design, as I said, defines the structure and the blueprint of the software before anything else. Okay, so I thought of showing this um, 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 Google um, sites about average salary. So I'm hoping you guys have some kind of a goal of what do you do after you graduate, okay? And I'm hoping you will be successful in your in your career after you graduate, and that is why I've been emphasizing this course to obtain as much experience in software development, so when you are interviewed for the job, you can tell a story or a narrative of what is your role in the development of a software uh, product. And so you will be able to answer questions about your experiences. Okay? All right, so that's the end of my lesson today. And as usual, be safe and healthy.